Hi, Max. Hi, Max.
Hey, how's it going?
Things are going fine. Things going okay for you in class? Just all reviews so far? In lecture?
Oh, in lecture.
Just pretty
Yeah,
much
I had
review?
I had some issues last night with some of the work, but it
What,
it was cleared up in today's lecture. So I
what's going
think I'm
on?
go. What's that?
What's going on?
Just some of the formulas I didn't really understand and like when to use them and stuff like that. Like we're learning about frequency and wavelength and stuff like that, and I just didn't know
Who do you have?
Selby.
Okay, she's going early on into quantum mechanics.
I know we took a literal quantum leap. It was crazy. Like we were talking about like basic, atomic properties and basic periodic table stuff. And then next thing you know, we're already on to quantum mechanics. So I was like, holy crap.
There are two philosophies about that. And one of them is to just throw you right into the deep end. And the other philosophy, I kind of like, I take a gentler approach. I literally get you into chemistry. I review everything from the intro. Then I hit you with gas laws and especially thermal. Thermal is where you're going to have the problems. That's where
Yeah.
everybody has problems.
Yeah.
But so you're okay with it? I take it you were doing E is equal to H nu, and
Um,
C is equal to frequency divided by wavelength, right?
right. So it's like we're dealing with like the energies of photons. So it's like Planck's constant times the speed of light over wavelength to figure out like how many nanometers. Yeah. So I
Yeah.
just like when I got to a problem on it last night, I was just like, all right, I have nanometers, but I don't know like what to plug it into and how to solve for it. So it was weird. We had a dynamic steady module the night before, and the lecture today explained what we were supposed to do the night before. So I spent 3 hours on the assignment. And I just was guessing at certain points. I was like hoping that I got the right answer, but I think I get it now.
Okay. It's just two formulas. Two formulas you have to deal with, and one is C is equal to frequency times lambda,
Yep.
and the other one is E is equal to H nu.
Yeah.
Are they getting into the Rydberg at all?
Um,
That's the one where the change in the energy is equal to the Rydberg constant. Uh, let's see, Rydberg constant. Oh God, I've forgotten it. You lose it after a second. Times 1 over nf squared minus 1 over n
yeah.
I.
Yeah.
You're
We
doing
did
that
that.
as well? Okay.
Yep.
Uh, that's just the third equation that you got to get in. You just have to be able to manipulate these things back and forth.
Yeah. Well, our like our problem set, like the dynamic steady module, there's not any hints or anything. It's kind of like you're either unsure, you're really sure, or you don't know. And then after you say you're unsure or you don't know, it will go back later and then explain it. Whereas like our problem sets for our next assignment, like you can view hints and stuff. So you can kind of like, see where you need to be in the problem and what formulas you need to incorporate to figure it out. So I don't know. I feel a lot more comfortable after today's lecture
Oh,
than
good,
I did
good.
last night doing it.
And again, Max, I'm another source for you. Okay.
Okay.
All right.
Appreciate it.
Hey guys, how we doing? Sorry, went off on a tangent there. We doing okay?
Yeah, I'm doing good.
Good. Happy to have you out there. Everybody, I was just asking Max, and same thing. I'm opening it for you too. Where are you guys doing? Max is doing quantum mechanics.
Well, Javier and Tin might be in the same boat as me.
Okay, you guys okay with
Yeah.
this? Javier, Tin?
I'm trying to get there.
Okay.
Yeah.
Are you doing okay with it? Do you kind of understand it? There are
Yeah, a little bit. Yeah.
there are basically two formulas you have to manipulate back and forth. And that is frequency times lambda is equal to the speed of light. And the other one is the energy is equal to the Planck's constant times frequency. And you basically have to manipulate those two back and forth. All right. I'm here. I'm here. If you have questions, please ask them. All right.
Thank you.
Thank you. Appreciate it.
Anything anybody else has? Anybody else? Where are you? Where are the rest of you in lecture?
We're just getting to chemical reactions in mine.
That is more along the lines where I would be in this
Yeah.
whole thing.
Who
Okay.
is your professor?
I have Kathy Mitchell as my professor.
I
But it's
had
strictly
her for
online.
intro. She was good.
Yeah, I also had her.
Yeah,
for
she's a
intro.
good teacher. She's very helpful too, even though it's like online class.
Yeah. Like I like Selby. He's a very knowledgeable guy, but he explains things like you're
Older
already
guy?
at his
Is he an
level.
older guy? Older guy? Balding,
40s, 50s.
balding and glasses.
No.
No.
Sorry, that's not the person I'm thinking of then. In any case, as I was telling Max, there are different philosophies. There are some people that like to kind of like ease you guys into this and go reviewing everything in intro first. And that's basically the first test. And there are other people that like to throw you into the deep end into quantum mechanics right away. Okay. There are reasons you do either way. Okay. Like for example, when you're doing quantum mechanics, you understand why when you go past calcium, all those other electrons get put into a d orbital, which is in a shell lower than the 4s. Does that make sense? Those of you that have had this, does that make sense to you? It helps to explain that.
Yeah. I
Other
guess
than that,
I guess intro to chem was like a brief introduction to the orbitals. Like they kind of told us like where everything on the periodic table lies. Like I remember like the first row, like helium and hydrogen are 1s, and then you go 2s,
2p,
2p, then 3s, 3p, and then 4s, 3d, and then yeah, and
4p.
so on. But I didn't know what they meant. I just knew that was the order that they went in.
It basically, that's all you get. You get a taste of it. You just get
Yeah.
thrown that stuff in the intro.
Yeah, and they teach you like the spin, like the possible spins of everything too, like depending on
Well,
where you're at.
You're going to get into quantum numbers now,
Yeah.
and that stuff's going to be real fun. Okay, I got Max. Adita, I have in here.
Hi.
Hi. Adita, what's your last name?
Parmar.
P-A-R. Why do I?
M-A-R.
Oh, I'm looking at the wrong roster. Let's look at the right roster and we might be able to get through this quicker. Thank you, Adita. Arthur's in. Okay, we got Carson. We got Charlie. Faye. Francisco. Who are you, Francisco? Pasquale. Yeah,
Yeah.
I got you.
All right.
No, there's no problem. James. Javier. Tin is in here. Samar. Do I see Doodley here? Is Doodley in? And Saki, is Saki in here?
Yes.
Thank you, Saki. Just couldn't see you. And there we go. All right, ladies and gentlemen, before we start, I'll open it again. Anybody have any questions about lecture? Because realistically, this is density. It's not that hard a subject, all right? I got through my lab last night in an hour. Okay, so I'm hoping we get through it that quickly today. So any questions, guys? What's your
As,
lect- Go ahead, Max.
as far as the syllabus quiz, I
It
just
should be
want to
still
know, like,
open.
I want to know, like, what I did. I thought I followed it to a T, the video on uploading the image, but
Okay, the only thing I can tell you, where am I at? Where am I at? There I am. Okay. Let's see where I'm. Do you mind, Max, if I show if I show this, then it's going to be observable to everybody. It's a syllabus quiz.
yeah, that's fine.
Okay, you're seeing my screen, right?
Yeah.
And Max, your last name?
Alexander.
Oh, crap. They do, for some reason or other, this thing automatically puts things into first name. Not good. Max is not big enough.
Well, that wasn't in the, it didn't say anything about what the size was or anything. Like, I just,
There's in the video does not give you a pixel size.
no.
All right. Somebody who has successfully completed this. Because honestly, it's who got 100% on the syllabus quiz or close to it. Come on.
I think I did.
Yeah, I did.
I would say, all right, would you mind going into the student forum? I believe there is a discussion group. Would you mind going into the student forum and please giving instructions on this? I'll be honest with you, if you've been successful in it, then you would give better instructions than I would. I'll be perfectly honest with you about that. So
Well,
you
see,
going,
I was gonna say the weird thing is about that when I actually did it the way it was shown in the video, it didn't even show the photo. But when I just controlled V to paste it, it worked.
again, like I said, there are tricks about this. I don't know. I've never been able to really be comfortable with this. Okay, down at the bottom in the course content, you see forum. Inside the forum, you access it just by clicking on it. And basically start a new thread, guys. Okay? And that's how you'll be able to talk back and forth to one another. Max, I don't know what to tell you other than that. I can.
I did the same thing and it wasn't, I followed the video exactly and it didn't work for me either. Or like I saw the picture pop up the same way
Yeah.
Max did, but I don't know what the pixel size is.
Right.
But
It
I followed the
doesn't
video
say,
exactly.
Yeah.
it doesn't say in the video, like, what size to use. It says use an appropriate sized image. So I was like, all right, well, this looks fine. And it showed up in the box. So I thought I had it. So the only thing I thought of, I scoured the internet for the Z87, like the correct, I thought it was like the wrong goggles that I picked. So I don't.
No, don't pick goggles. Pick the interesting. I don't care to see goggles. I see 20 million goggles. Give me something that's interesting.
Yeah, but the directions say to use goggles.
I don't care. I'm the one looking at it. Give me a picture give me something interesting, Max. Give me a picture of a sunrise coming over the earth.
All right. So does someone have the image that they use in like the correct size so I can just use that? Because it seems kind of
Does somebody
silly
have the correct size?
to get an F on a syllabus quiz. I don't want to like
Max, you're not going to get an F.
what it is right now.
Yeah, well, it is right now, but all you got to do is put the picture up there. It'll be a
Oh, so I
100.
have another opportunity.
Yeah, you have as many opportunities. Let me see how many I gave you. Trust me on this, okay? I'm not going to screw you on this.
Oh,
I'm
we
gonna
have
make
until the
sure
23rd.
everybody's gonna have close to 100% on this thing by the end. I think it's an assessment. Look, see Max, do you see this?
Yeah, but when is what is the date, the deadline?
You're really cynical. You don't trust me at all, do you, Max?
I don't want an F.
Look at that, Max. You see the end date?
All right, I got you.
Are you happy now?
I trust you.
All right, Max, I would whatever you used before, make it bigger. Okay?
It wants it bigger. Okay.
Yeah, that's the trouble right now. You uploaded the picture successfully. It's just too small. You see, if I look at that picture that you showed me, I wouldn't be able to see any details. Fair enough?
Okay. Well,
So-
if someone could just tell me the right size, that would be great. Whoever did it right.
I will look into it myself, Max.
Thank
All
you.
right. Good enough. Anything anybody else has? Anything? In that case, let's get on with it. All right, let's go screen share. Okay, density. Density is probably the easiest thing that you are going to be dealing with. One of the easiest formulas you're dealing with, because what you're dealing with is you've got three different variables. You've got mass, density, and volume. Okay? You will either be given two of the three things and asked to solve for the third, or you will be given means to get two of the three things and asked to solve for a third. Now, you may get a little bit of a funky problem. All right, if somebody is smart, they'll do something. I thought this problem was absolutely brilliant the first time I saw it. And basically the problem was this. They gave you a sheet of aluminum foil. They told you it was 8.5 by 11. They told you the weight of the aluminum foil, and they told you the density of aluminum. The question was, how thick is it? Now, what you had to realize is, okay, they're giving me the mass, they're giving me the density. All right. If I look at the density triangle, if I had the mass and the density, I know immediately, because there's a line between the mass and the density, I know that if I divide the mass by the density, I'm going to get the volume. Okay. Now, if I have the volume, don't I have two of the three criteria to get the volume? I have the length and the width. The only thing I'm missing is the height. So again, there might be a problem like that. But as a general rule, when you're doing density problem, usually what happens is they give you density to make you solve for something else. It's like they want to give you an extra step in the problem. So they'll give you the density and the volume. That way you have the mass. Does this make sense, guys?
Yeah.
I'm talking
Yes.
about generally lecture strategy on word problems using density. Okay, so there are two ways I try and teach density. One is through what's called the density triangle. And that simply is you put the mass on top, put a line, and then you have the density and the volume underneath. Now, because you have that line, the line in a fraction means divided by. So if you have the mass and the density, because there's a line between the mass and the density, in order to get the volume, you divide the mass by the density, you will get the volume. All right. If you have the mass and the volume and you want the density, again, there is a line between the mass and the volume. So you divide the mass by the volume, you get the density. The third thing, if you have the density and the volume, if you have the density and the volume, they're right beside each other, no line between them. So if they're right beside each other, and what you're going to do then is you're going to multiply the density by the volume, you will get the mass. Okay. Let me see if I need to add a slide or not. Yes, I do not need to slide. Okay, that's how to view this in the density triangle. If you can see this, some people can see this visually and be able to say, oh, that makes a whole lot of sense. There are other people that need to have something put on paper, and they need to see the dimensional analysis aspect of this. In other words, we're going to use the labels. All right. The labels of the three things in question. Generally speaking, we're going to have mass. Mass is going to be some kind of weight label, grams, pounds, ounces, something like that. Volume is going to be some kind of a volume label, milliliters, quarts, gallons, something of that nature. Now, in order to get the density, you divide the mass by the volume. So what you're going to get is you're going to get a mass per volume label. Generally speaking, when we're comparing things to charts, we generally speak in terms of grams. They list it in charts as grams per centimeter cubed. But what you have to realize is a centimeter cubed equals 1 cc, cubic centimeter, that makes sense, which equals 1 milliliter. All three of those values are equal to one another. So you can literally interchange them. If you get something given to you in grams per milliliter, immediately say, okay, well, that can be grams per centimeter cubed. All right. Now, let's think if we're given two of the things. Say we're given the volume and we're given the density, and we're asked to determine the mass. All right. If we're given the volume in milliliters and the density in grams per milliliter, well, what we want to end up with are grams. So I need to get rid of the milliliters in the density, and I can do that by multiplying it by the volume. The labels cancel. The only thing I'm left with is grams. Are we good with this, guys? Make sense?
Yes.
Yep.
All right. Now, let's say I have the let's say I have the mass and I have the, I'm sorry, I just confused myself here, guys. So I went with volume times density. All right. If I have the mass and the volume, okay, the mass is in grams, volume is in milliliters, but my density is in grams per milliliter. So just looking at it straight, if I have grams and I have milliliters and I want to end up with grams per milliliter, then all I have to do is divide the mass by the volume. I'm going to get the density. Third one is a little bit possibly confusing. If you have the mass and you have the density, the mass is in grams and the density is in grams per 1 milliliter. When they say grams per milliliter, that is 1. All right. If we have the mass and we have the density, we have to kind of think, well, how am I going to end up with milliliters? All right. The only way to get milliliters on the top is to look at the density, and you got to make it the inverse. So in effect, what I'm doing is I'm going to take the mass and I'm going to multiply it by the inverse of the density. I'm going to put 1 milliliter over however many grams are in that milliliter. Grams are going to cancel. I'm left with milliliters. So what I've just done by making the reciprocal is I've actually divided by the density. Make sense? Saki's shaking her head, so it must make sense. Right, Saki? All right. Now, can we measure the volume of a liquid directly? In other words, can we pour it into something and just read what the volume is?
No.
Charlie, can we do that?
No.
You can't? If you had a graduated cylinder, it's marked with lines that say how many milliliters, right? You have
I
that
missed the-
graduated cylinder and you pour a liquid in there. Can you not read how much volume is in that graduated cylinder?
I missed the first half of what you said. Yes. You can
Okay.
do
So
that.
yes, you can. Now, Charlie, do you have a bathroom scale somewhere in your house?
Yes.
All right. What I want you to do right now is I want you to go to the kitchen, grab a handful of water, bring it back to that scale, and put it on the scale and tell me how much it weighs.
I'll drink
Go,
it
go,
first.
go. Go. You're not going.
I can put it in a cup.
Ah. You have to have something to weigh it in, don't you? In order to get the weight of a liquid, you can't get it directly. So what you have to do is you have to put it in something. And what you have to do there is you have to put that something, that vessel, on the balance, get the weight of it, and then put the liquid in. Then you will have the weight of your liquid. Now, it only makes sense. Are you lazy, Charlie? Are you
Am
a
I
lazy
lazy?
person?
Sometimes.
Do you like to do work that's unnecessary?
No.
All right. So, are you going to choose a container that's already marked to weigh it? Or are you going to choose some amorphous, a cup that doesn't have any lines in it, and then pour it into the lined container?
Preferably a measuring cup.
Absolutely. That only makes sense. So what you're going to do is you're going to put a vessel that has markings on it to determine the volume of your liquid. You're going to put that on the balance. You're going to get the weight. Then you're going to pour the liquid in. You're going to read how much the volume is. And you're going to put that liquid and cylinder back on the balance. Now, Charlie, how are you going to get the weight?
By putting it on a scale.
All right, you put it on the scale. I just said I did that. How are you going to get the weight of the liquid?
By subtracting the vessel from the weight of the liquid. So measuring the vessel first.
Yeah, I know it's simple, but sometimes it's the simplest things that elude us. To get the weight of the liquid, you're going to take the liquid weight and cylinder weight, subtract the weight of the empty cylinder, you'll get the weight of the liquid. Simple enough. So if I have a cylinder, it weighs 32.643 grams. If I have the cylinder and the liquid, weighs 42.893. Simply to get the weight of the liquid, I got to subtract the 42.893 and the 32.643. This gives me a weight of 10.250 grams. Simple enough. Now, if I looked at it and I saw that the volume was 10.2 milliliters in my graduated cylinder, then I know what the volume is. To get the density, I divide the mass by the volume. I'm good. Simple enough? Easy peasy?
Yes.
Okay. Now let's go with solids. Let's go with solids. Let's see who I want to talk to. Tim.
Yes, sir.
All right. We just said that you can measure the volume of a liquid directly, but you can't measure the mass of the volume directly, right? Make
Right.
sense?
Yeah.
What about solids? Any solid you have, can you get a weight of it?
Yeah.
All right, so you can measure the mass of a solid directly, right, Tim?
Yep.
What about the volume?
Don't you have to find the density of this?
No. Nope. You are trying, that's what you're trying to determine is the density. In order to determine the density, you need the mass and you need the volume. We just got done saying, you agreed with me that we can measure the mass of a solid directly. Can you measure the volume directly?
No.
All right. Let me
'Cause-
see if I can
'cause-
find something. Okay, we're gonna go with this. Tim, we have a book, right?
Right.
All right. Now, Tim, can you measure the length or the width of the book?
Yeah.
Can you measure the length of the book?
Yeah.
Can you measure the height of the book?
Yeah.
Okay. So if you have the measurements, length, width, and height, can you tell me what the volume of this book is?
Yes.
So sometimes you can determine the volume of a liquid, if of a solid, if it is regularly shaped. For example,
I was thinking about a rock, so we put it in the beaker, so we measure like the water, and then we subtract it. That's why I imagine.
I understand, Tim, but you got to understand that sometimes you can do it if you have a regularly shaped object. You can get the volume that way. That makes sense?
Yeah.
So if you have a sphere, generally speaking, when you have like a ball, it's hard to measure radiuses. So what you do with a ball, you measure the diameter divided by 2. That will give you your radius. And if you have a sphere, you then plug it into the formula. Volume of the sphere, 4/3 pi 3.14 times the radius cubed. We've already agreed that the volume of a block is length times width times height. If we have a cylinder, what you have to do is you have to measure the height of the cylinder. Again, you're going to measure the radius of the circle, divide that by 2, and you're going to get the volume of the cylinder to be the height times 3.14 times the radius squared. As long as you have a regularly shaped object, you can get the volume of that object. Bar has a length 7.8, width of 4.75, and a height of 1.45. Its mass is 354. What is its density? First step, got to find the volume. You have the 3 measurements, multiply them by each other. You end up with a volume of 53.7 centimeters cubed. Okay. Now you've already been given the mass. You've figured out the volume. All you got to do is divide the 2. Divide 354 by 53.7, and you end up with a mass of 6.59 grams per milliliter. Notice I interchangeably went from centimeters cubed to milliliters. Any questions about a regularly shaped object?
There were some problems like this on the pre-lab and with significant figures that I got wrong for some reason, but I couldn't figure out why.
Charlie, I will be happy to go over it with you after class, okay?
Okay.
That's my rule. I don't mind going over quizzes, but I don't like to take class time to do that, all right?
But to confirm, like we are doing significant figures with these calculations.
Yes, absolutely. That may be very much why you got it marked wrong. All right, I'll look into it and we'll see. Fair enough?
That works.
All right. Now I got to tell you a story, guys. Way back, way back in ancient Greek times, this Greek king, he used to have this little kingdom that was right on his side. And every so often he'd go and beat the snot out of this kingdom. Now, the little kingdom, the king of the little kingdom, kind of got tired of this. So he thought, maybe if I appease this guy by giving him this gold crown, maybe he'll leave me alone for a while. So he gives this king this gold crown. Now, if you've been bullying something, would you trust somebody that they've given you something? So the Greek king is saying, I don't know if I trust this to be made of pure gold. So he called in his famous Greek geek called Archimedes. He said, Archie, I got a proposal for you. You got to tell me whether this crown is made completely of gold. And you got to do it in a week. And you can't mar this crown in any fashion. And if you don't do it in a week, I'm going to kill you. So this kind of concerned Archie. So he kind of paced and fretted. He knew that if he could find the density of the crown and compare it to gold's density, he'd know if he had a pure crown or not. And he knew he could weigh it, but he couldn't figure out how to get the volume. So he paced and fretted and paced. Comes around Thursday, he's starting to get really concerned. So he goes to the place where he does his best thinking, the bathroom. And he fills a tub with some nice lukewarm water. He's going to relax. So just as he's getting his tush in that tub, he starts seeing the water come out. And then all of a sudden it comes to him. You know, if I put myself in this tub, the amount of water that comes out is going to be equal to me. And he came up with Archimedes' principle. And that is that if you put a solid into a liquid, the liquid will be displaced the same amount of volume that the solid has. So if we have a irregularly shaped solid, what we're going to do is we are going to fill a vessel with liquid. Now you got to understand when you're doing it, you got to put enough liquid in there that's going to cover the solid. You're going to note the amount of liquid you put in there first. Then, guys, when you do this, please remember you're using glass graduated cylinders. So don't gedunk the thing. Don't like take it from a level of like 3 meters above the graduated cylinder and see if you can hit the graduated cylinder, because guaranteed you're going to break it. Plus, you're going to get water splashing out. If you get water splashing out, then what happens is you're going to get an inaccurate volume reading. So what you do is you take the graduated cylinder and you tip it. And then you take your solid and you kind of slide it in, gradually increasing the distance so it slides gently into the liquid. Then you measure the final volume. The volume of the solid is going to be the final volume minus the initial volume. So I have the solid I've weighed. It ends up weighing 6.543 grams. I measured the volume initially at 17.8. Final volume was 25.3. I subtracted 2. That's 7.5 milliliters. Divide that into my mass. I get a density of 0.87 grams per milliliter. We good with this, guys?
Yes.
Now, the last way you are going to have to determine this is you are going to have to graph this. I believe we have a graphing, if I am not mistaken. No, we don't. There is no graphing lesson this semester. Sometimes they will put a graphing lesson in if we have an extra day. So the only graphing you're going to get is what I give you right here. When you get graphing, Faye, let me ask you a question, Faye.
Yes.
Your life depends on this. If you get the answer wrong, you're going to die.
Okay.
No pressure. Okay? So, Faye, you have to determine a density absolutely. Are you just going to do one measurement of the mass and one measurement of the volume?
No, like 4 trials.
You're gonna
Maybe.
just 4? Hell, if it's my life, I'm gonna do more than that.
10.
I'm gonna keep on doing it until this guy gets tired of watching me doing it. Now, I'm gonna do a whole bunch of trials. That's the whole idea, right? And
Yes.
I'm not just gonna do the same one over and over again. I'm gonna do different masses to determine different volumes. Does that make sense to you, Faye? I'm gonna vary the size of it to see
Yes.
if the density stays the same.
Yes.
Make sense?
hmm
So if I do more trials, I'm going to feel better about the final result I get. That's what you're doing when you are doing graphing. What you're doing is you are controlling one thing and you are allowing the other thing to vary because of the one thing that you're controlling. You have two variables that are dependent on each other in density. Mass and volume are dependent upon one another. So what you're going to do is you're going to control how much volume you have, and you're going to graph that on the x-axis. You're going to see how much the mass changes and graph that on the y-axis. Now, because density is equal to grams divided by milliliters plus 0. That is the equation of a straight line, guys. Density, if we plot mass versus volume, we get the equation of a straight line because the mass is equal to the density times the volume plus 0, because when you have no mass, you have no volume. So the y-intercept is going to be 0. We have a straight line. Now, when you are doing this experimentally, what's going to happen is you are going to have variance. You're going to have experimental errors. So let's say your first data point was 1.5 in 20. Your second one was 3.0 in 20. Your third one was maybe 50 and 4.5. Your fourth one was 40 and 6.0. So when I'm plotting these things, I got one above, one below, one above, one below. This is, I've got points here. Now, the whole purpose behind doing the graphing, I could do this. I could take all the points and just simply average all the densities, right? Couldn't I do that? Couldn't I do that?
Yes.
But if I plot them out, what happens is I can draw a straight line such that I'm giving equal impact to the errors that are high and errors that are low by putting an equal amount of the points above the line and below the line. In effect, what I'm doing is I'm averaging out experimental errors when I'm doing that. Okay? Does that make sense, guys? But when you do it, you cannot use data points. You cannot use data points to figure out your slope. Okay? So what you're going to do is you're going to find a point. You see kind of like where the block has a corner with the X and the Y? You're going to look on the graph to see a point where the line goes through that corner. Then you're going to take that point down all the way, over all the way. Now, if I look at the point that's at 20, it goes right through the corner right there. I drop that right down. So at this point where is on the line 20 and it intersects the line. That's going right through the corner of a block. So I know that my Y value is 20. My X value, if I take that down and figure it out, is going to be 2.5. I find another place where it goes through the corner. That's right here. Where it goes right through the corner, the Y value is 40. X value is 4.75. I have my 2 points. Again, you cannot use data points when you're doing this. If you use data points, why did you bother doing the graph? So now I have my 2 data points. How do we get slope? James, how do we get slope? If I have 2 points, James, how am I going to get the slope of that line?
You divide rise over run.
Rise over run. In other words, the change in the Y value divided by the change in the X value. For my points here, my Y values are 40 and 20. So I divide 40 grams or subtract 40 grams and 20 grams, and I get 20 grams. I'm going to divide that by the change in the X value. 4.75 minus 2.5 gets me 2.25. I divide those two numbers and I end up with 8.89. If I carry over the labels, guys, the Y values are in grams. X values are in cubic centimeters or milliliters. So what I'm in effect doing by taking the rise over the run, I'm dividing grams by milliliters. I'm getting the density. Questions, guys? Okay. I'm going to end the slide show here for a second because I know I forgot to put something in. I know I forgot to put something in here. All graphs, take this notes. All graphs must have a title. The title can be something as simple as y-axis versus x-axis, grams versus milliliters. Can be something as simple as, okay, if you're plotting for density of the sample. Axes must be labeled. You need to know what you're graphing. X-axis being milliliters, y-axis being grams. X-axis being concentration, y-axis being absorption. I need to know what those are. Units of the axis must be labeled. It doesn't do me any good if I know that my y-axis is mass if I don't tell you that it's grams. It could be pounds, ounces, anything. I need to know what that axis label is. Each axis must have a scale. In other words, axis must, you must tell me what each block is worth in the X direction and in the Y direction. So you basically have to delineate with numbers what each block is worth. By the way, if you submit a graph that is not on graph paper, you get a 0. You're supplied. You are supplied in the course. You're supplied with a template for graph paper. Use it. If you use graph paper that is any larger than that, you will get 10% of the grade. I want it on graph paper that fine. Last thing. A graph must cover 70% of the graphing surface. The more surface of the graph paper that the graph covers, the more accurate your graph is. So when I'm looking at graphs, I'm looking at these things. I've got a bunch of data here. I've got volumes and I've got masses here. So how do I ensure that I'm covering 70% of the surface? Guys, I didn't know about any of this crap when I was learning how to graph. So basically, you know what happened? I would start out my graph. I would go individual lines, Y and X axis. And I would do my X axis. This isn't covering enough. Take my eraser, try it again. Take my eraser. Eventually, I would rub a hole in the graph paper, so I'd have to go get another piece of graph paper. You don't have to use this. I don't care how you get 70% of the graphing surface covered. I don't care about that. What I do care about is that it is covered. So the way you do this, you need to determine the range that you need to graph. The way you do the range is you subtract the high and low values. Then to get the scale, all you got to do is take the range and divide it by the number of boxes you have. If I am looking at my X values here, I'm plotting volume on the X graph, X axis. Then my high value is 45.9. My low value is 32.5. So that means my range is going to be 45.9 minus 32.5 or 13.4. I'm going to divide that number by the number of boxes on the X axis. I do that math out and I get 0.67 milliliters per box. So ideally, if I'm going to cover the entire 20 boxes with my graph, each little box is going to be worth 0.67 milliliters. Couple things I want to point out. When I do this range, I am no longer graphing at the origin. If you start at the origin, you're wasting too much graph paper. What I've done is I've moved the graph off the origin, so I'm still in the first quadrant, but I am not at the 0, 0 point. At this point, my X value at the corner of my graph is going to be 32.5. Second thing I want to point out, 0.67 is a pain in the ass to graph because it's not an even number. I can raise that value. I cannot lower that value. If I try and go to something like 0.6, you will find that you don't have enough graphing surface to plot your final value, to plot your highest value. That's the reason you cannot lower this number, but you can raise it. Can anybody suggest something that would be fairly even?
0.7.
I'm sorry, hold on 1 second, guys. Thank God for answering machines. I could use 0.7. I can use 0.7. Is there something that might be even more even easier to graph than 0.7?
1.
1.0.
You could do 1, but I'm thinking that if you do 1, that's going to be too high a measurement.
0.75.
If you do 0.75, then each second block is 1.5, each fourth block is 3. You can do the scale. It has nice even numbers there. Does that make sense to you? So if I was going to do this, I would try and do it from 0.75. Okay? It's easier to graph. Again, if you want to go through the pain of trying to do 0.67, that's fine. That's fine. But again, I'm only concerned with getting 70% of that graphing surface covered. Okay. Yeah. What am I doing? Yeah. I do the same thing with the Y. Only I've decided that the Y has only 15 boxes in it. Again, I do the range, which was 89.3 minus 62.5. I divide that by the 15, and I end up with 1.78 grams per box. Okay. The next easy number to graph would be 2 grams per box. Now, if I want to figure out the range of my graphing, if I have 2 grams per box and I have 15 boxes, then I just multiply the two numbers together, and this means that I have the capability of graphing 30 grams. Does that make sense to you all? By the way, you can click me off at this point. If you, James just got a strange thing. I'm going into mathematics here. I'm proving how to do a graph mathematically before you actually do it. So if you want to turn me off right now, you can. This is extra information, I guess, is what I'm saying. Does everybody see that I have the capability of graphing 30 grams if each box is worth 2 grams per box and I have 15 boxes? Do you see that?
Yes.
All right. If I add 30 to the 62.5, that gives me a total value. The amount that I can graph is going to be 92.5. Does that make sense to you? All right. Now, the area of the graph that I'm not using, my highest value is 89.3, right? Does that make sense? The highest value that I have to graph, my highest value that I have in my data is 89.3, but I have the capability of graphing up to 92.5, right? So this means that area from 92.5 to 89.3, I'm not using. Okay? So if I get 92.5 minus 89.3. God, what do we do before calculators? This gives me a value of 3.2. Those are the amount of grams that I am not graphing. But remember, I've got 2 grams per box. So literally speaking, if I divide my 3.2 grams by 2 grams per box, this means I'm not using 1.6 boxes. What this means to you, out of the 15 boxes, I am not using 1.6 of them. So this means that I'm definitely covering 70% of the graphing surface. Again, that last little bit, you didn't have to really know.
Wouldn't the height of the graphing paper be larger than the width?
Yeah, usually I turned the paper on this horizontal. I was doing a landscape graph as opposed to a portrait, okay?
Oh, okay.
I think that's the last, if I'm not mistaken, that is the last thing.
Professor, you added the 30 grams to the 62.5 because that's your starting point, right?
The
There's no
62
zero anymore.
the 62.5 is the starting point for the y-axis. So yes, you are correct. I added my range of 30 grams. I have the capability of graphing 30 grams. So this means I can graph from 62.5 all the way up to 92.5.
Okay, thank you.
Better yet, ladies and gentlemen, learn how to graph on Excel. Okay? The only reason I went through this is because you're going to be asked in the results section to provide a graph to me. You're going to have to do another graph later in the semester. And for that other graph, I'm going to teach you how to do it Excel. Ladies and gentlemen, you are never going to have to hand graph again in your life unless some professor is silly enough to make you do it. Some professors believe that you actually have to hand graph it to get a tensile feel for graphing, to feel what it means. But I'm going to go through and show you how to graph in Excel later. Okay, I go through a couple calculations. And they're nothing really more than some of the calculations that we had before. Okay, so it's just extra calculations there at the end of this PowerPoint. Now, let's get into the crux of what you have to do. And that is going to be in course content. All right. Now, does everybody see the columns on the left here? You're not going to have to, it's a good idea to look at the videos, but you don't really have to. All you got to do is move down the left side till you see a column set that says student data for labs. Are you seeing that, ladies and gentlemen? Click on it. Then you're going to have to go back up and click on the dry lab data tables. This is where you're going to access. This is where you're going to access all of the data for the rest of the labs for the semester. Well, most of them anyway. So you're just going to take this down. That is all. This is where the data for the density lab is. It's giving you the masses there, the dimensions of the aluminum bar, the amount of water displaced by the glass sphere, and then you're going to have, you have the weight of a dry Erlenmeyer flask, and it's going to tell you how many milliliters of water you add to it. Then it's going to give you the weight of the Erlenmeyer flask and just that amount of water. So the second trial, you add 5 milliliters on top of 5. So you have now an approximate 10 milliliters, and you have the mass of the Erlenmeyer and the 10 milliliters. Is that understood? We got that fairly easy? All right. Guys, you're going to love this. This is going to be very, very easy for you. I'm going to go through, I'm going to call up the lab manual. And call up the lab manual. And I'm going to go straight to the procedures for this particular lab. Just to show you what you are going to have to do. Procedure. That's the wrong thing. Wrong lab. Yay, density. Part A, you're going to have an aluminum bar and a glass sphere. Weigh them. All right. Part B, you're going to have an aluminum bar. You're going to need to measure length, height, and width of that bar and determine the density of it. Second thing, you're going to have a glass sphere. You're going to need to determine the volume of this by liquid displacement. Measure the liquid in the graduated cylinder, add the glass sphere, measure the liquid after the sphere has been added, subtract the two out. Then part C, you have the mass of the aluminum bar, you have the volume, determine the density. Mass of the glass sphere, volume, determine the density. And guys, the reason I'm going through so fast is it really is not rocket science. Now, you can read through the procedures here, and you're going to have to submit it in your notebook. Okay? Normally, what they did was they have a Erlenmeyer flask that you weigh beforehand. Then you use a burette. You note the volume in the burette before you start. You add about 5 milliliters, stop it, and you determine the final volume. The volume that is listed in your student data is the subtracted volume of the initial volume from the volume that got put into the Erlenmeyer. You subtract those two numbers, that's how you got that volume. You now have water in your Erlenmeyer. You've already weighed the Erlenmeyer, put the water on the balance. You have the weight of the 5 milliliters and the Erlenmeyer. Subtract the two values, you have the weight of the liquid. You do that 5 more times, adding 5 milliliters each time. Then you go through the recorded data. Guys, if you want to use this, good. I think it's too lengthy. If you want to use it, if you want to type it up and or you want to print it out and paste it into your notebook, fine. But you have to paste it in your notebook. If it's loose, it doesn't count. So basically, this goes through all the data you would have collected. Now, the funky thing about this is the results section. This is the only time I know of this semester that you'll have to go into the post lab. The post lab part 3 tells you to plot the mass and volume on a graph. That's all you have to do with this. I'm going to go through the results section. Just so you can see how simple it is. And then I will be out of here. And I'm sorry, I've taken a little longer than an hour. Must have been the Archimedes story. Results. Preview. Start quiz. All right. Guys, this is going to be really hard. This first question may be the determination of your score for the semester. Question 1. What is the mass of the aluminum bar? What is the mass of the glass sphere? Remember, in the student data, we gave you that information. Just transfer it over. You get 10 points. Actually, I should make this a qualification. If you don't get this answer right, you flunk the class. Just transfer the numbers over, please. Here, now, we have a text box here. So, as I explained in the orientation, when you have a text box and you have a calculation, you have to show me the number, the label of the number, description of it. It's good for me to do this so I know how much pain it is for you guys. It'd help if I spelled volume right. All right. I have the number, I have the label, I have the description, and I have the operation. I need to see all four of those things in each calculation, guys. Don't have the description. If you don't have the description, you get no points. I got to make it harsh like that because if I don't, then there are people that would just go ahead and lose the points and get the 70% or whatever I put it down to. So we good with this? We understand what we have to do in the text boxes.
Yes.
All right, next thing, you're going to have to show the density calculations of the aluminum bar and the glass sphere. Next question. All right, you only need to show one in here. It's asking for trial 2. If you want to, I don't really care which one you do. I just need to see one value where you are going to show me the calculation of the volume of the liquid and the calculation of the density. Remember, it has to go from birth to death. So if you just show me the density calculation here, you get only 20 points because you haven't shown me all the calculations. I need you to show me the volume and the density calculation here. And last thing, you have to upload a picture. So Max, learn how many pixels you need. Got to upload a picture of the graph. It's worth 20 points. Easy peasy.
Yes.
Where do I learn that?
Where do you learn that? At this point, Max, I would say trial and error, or hopefully somebody will tell you the amount of pixels. I want you to try and do this. I want you to give it a good attempt. If I don't get it, I'll probably ask you to put it in the, better yet, Max, here's the solution. Include your graph in your notebook, okay? If you include it in your notebook, you're putting it into a Dropbox and I can see it. Finest kind?
Sounds good.
All right. That's all I got. I told you it'd be about an hour. Anybody concerned about this?
What did you say for question 4?
Question 4 is, it's a density calculation of the liquid. Part of what you're doing is you're doing 5 measurements of 5 volumes of water. Okay? And what question 4 wants you to do is to determine by calculation what the density of one of the trials is. Just one. That's all you need to show is just one. So for this, you are going to show the weight of the water and Erlenmeyer. You're going to subtract the weight of the Erlenmeyer. That will give you the weight of the water. That's the first calculation. The second calculation is the density calculation. Okay? That's all I really need here. C, part C, you do not need to do. To make it nice, show me the mass of the empty flask. Show me the calculation for the mass. The volume has been given to you. Don't worry about it. Show the density. Just show me the mass, calculation of the mass of water, and the density calculation. Any other questions, ladies and gentlemen?
Yeah. So do we use the trials to graph the?
Yes.
Oh,
Yes.
okay. Gotcha.
And remember, when you're doing the trials, you are not subtracting it from the previous trial. All right. What you're subtracting it from is the initial Erlenmeyer flask empty. And you are putting in the total volume of the liquid. Guys, if that's it, that's all I got for you.
Thanks, Professor.
Charlie, Charlie, were you the one asking me the question?
Yeah, I was.
All right, I can get to it now.
Okay.
Guys,
Thank
if
you.
you don't have anything, then I will see you next Wednesday. Good luck. And remember to email me your questions on lecture or lab, in either case.
Thank you, Professor. Have a good day.
Charlie, yeah,
Thank
have a
you.
good day. Have a good day, guys. Charlie, do you mind if I show it while class is here, or do you want this to be private?
I really don't mind either way.
Okay. In that case, if you don't mind, then I am going to just,
Yeah, I think I'm with her too. Like I understand multiplication, division for significant figures, but when I get confused is addition and subtraction.
okay. All right, Charlie, just hold on a second. This hopefully is going to be an easy question, all right? Okay. All right. Max, do you see these two subtraction numbers?
Yeah.
When I am doing addition and subtraction, my answer can only go to the right as far as my least precise number. Now, if I'm looking at these two numbers, the top one goes all the way to the thousandth place. So that's a pretty precise measurement, right?
Yeah.
The bottom one only goes to the tens place. So if
So
I'm
it'd be-
doing this, you answer, how many places past the decimal can you report this out?
So it'd be like 42.3.
You have to do the rough math.
Point, yeah, 364, but then it would be 42.3 because least. Okay.
No, 4.4,
Oh, because you round up. Yeah.
because you round up.
Okay.
Okay.
Got
Now,
it. Okay.
the other thing, if you have 45,000 and you are adding, say, okay. Now, the 45,000, that is only precise to the thousands place. The 4542 is accurate to the units place. Just like we did up here, this can only be reported out to the thousands place. So I add these two numbers up. Okay. The 9 is the last number I can report out. So this is actually 50,000.
Okay.
All right. Now, an interesting point. How do I show that the first 0 is the only significant one?
You put a period at the end.
If I put a period at the end, that means all those zeros are significant.
Okay.
because the rule says if you have a decimal point, all the trailing zeros are significant. The way you there are two ways to show that
Oh, write it
only
in scientific notation.
write it in scientific notation is the one that you should be doing. That's an engineering citation. This is the same thing as
10 to the fourth.
same thing. They're equivalent to one another. This is just easier to write. It makes more sense. Okay. All right. Does everything I'm saying make sense to you?
Yeah.
Now I'm going to throw you a couple of anomalies at you. Okay. Now, Max, the top number, what's it accurate to? Which place?
The hundredths,
the top one.
hundreds.
The bottom one is to the hundredths. The
I meant-
top one.
Not hundredths, but hundreds.
No. This goes, remember, the first place. This is where the decimal is. So
It's
the furthest to the
accurate.
right, the furthest to
The
the right
one.
is the units place, the ones place. Okay? So the top only goes, it's only as precise to the ones place, right, Max?
Okay.
So that's the place that I can report it to. So I add this up. So the one just to the left of the decimal place is the one, it's the last number I can report out as being significant. Because the 999 is limiting me to that. Which means that I have to report this out as 1001. Does that part make sense to you, Max?
Not as much, but I'm trying to compartmentalize it.
If I put a period there, does that
Oh.
make sense to you?
Yeah.
All right. Now I want to point something out to you. How many sig figs does this have?
3,
How many does this have?
3,
How many should your final answer have?
4.
So you can add numbers and increase the number of significant figures. You have to report this out as 1001. Have to. All right. By the same token, you can have okay? If I subtract things, and I just outsmarted myself because I have to use a calculator now. I could probably have done it. All right, Max. We have to figure out. All right, we have to figure out what the last place is that we can report out. What's the last significant, what place is the last significant number in 11,200?
Well, I know there's 3 significant figures in the top one.
But what's the last place what is the place that's
100.
What's the 2? What place is the 2 in?
100.
100. So that is the last place that's significant in the top number, correct?
Right.
So the bottom number,
Just
which
the
place?
tens.
Tens place. So we have a choice of hundreds or tens. Which is the least precise?
The tens.
Okay, you're able to measure 110 gallons of milk accurately, or you're able to measure 100 gallons of milk. Which is the more accurate measurement, 100 or 110? Which gives you the smaller number?
110 is more
110
accurate.
is more accurate. Okay, so the 11,200 is less precise than 3,980. Does that make sense? What you're
Yeah.
looking at the significant figures going to the right. This one only goes to the right to the hundreds place. This one goes to the tens place. So the last one you can report out is the least precise number, the one that goes to the right the least. That is the 11,200. So this means that I have to report this out as 7,200,
7,200.
or more likely 7.2 e to the 3. All right. Now,
So it has to be to the first number. It can't be to the second number in the subtraction or addition.
I'll give you another example. These could flip. Okay, Charlie? It doesn't always have to be the top number. It just so suppose it just happens that in both of these cases, it was the top number. I'll give you an example in a second where it's the bottom number. All right.
Okay, because I thought I had it, and then that
right.
just messed me up.
All right.
Yeah, I
Again,
don't mean to like take over either. I hope this is answering what you like, what questions you had, Charlie.
Well, originally in the quiz, I like figured it out, and I think I understand like why I got those wrong. But now that it contradicted what I had just learned.
Were you stuck on the last one where it was like 14.45?
Yeah, I put 14.5, and I think because it was addition, you have to do it to the hundredths place. So then it would be 14.45, and I put 14.5, right?
Yeah.
Okay.
okay. Now the point I was trying to make here, how many sig figs does the top line have?
3.
3. Oh, sorry.
Bottom line?
3.
3. That's 0. There's no decimal point there. So that 0 is not significant.
Yeah,
Okay.
sorry.
So we ended up with how many?
With 3.
2. No, 7.2 e to the 3rd. That's the answer. That's the correct answer because we can only report it out to the hundredths place. So we have to report it out as 7,200. Charlie?
I'm right there with you, Charlie.
All right.
I'm right there with you.
Let's
I
go
don't
back.
get it. Like multiplication division is so easy, but then like the subtraction and addition one is way harder.
All right. You can own, you're looking. All right. Do you see how I have the numbers set up in real neat columns?
Yeah.
All right. So look at the numbers. This one only goes that far. Everything else is insignificant. Okay. This one goes that far. So if I have these lined up in real neat columns, the one that goes to the right, the least, just draw a straight line down. You just draw a straight line down. This means that the first 2 is going to be the last significant figure you can report.
Oh, I see.
Got it. Okay.
That makes sense to you?
That line
Yeah.
helps.
All right.
Okay.
All right. Now you ask another question, Charlie, and I'm going to just erase all this stuff for now. All right, say we have,
I actually just had a,
I'm sorry, Samara,
yeah, I was just gonna ask 2 questions for the lab. So what we want us to do is once we've done it, just print out that and the graph and just kind of staple it into our notebook.
okay, the graph.
Because I have a physical notebook. So
Yeah, okay, yeah, Samara, you need to have a physical notebook. What you need to do is you need to go back. If you don't remember what I went through in the notebook, in the course content. Guys, I'm gonna have to get out of here for a second because
Yeah, it's
well,
in the
I mean,
lab. It's in the lab manual.
I know that. I'm just asking, so do I basically just like save that like to a Word document, then print out the Word document and then put it in the notebook? Because you're saying I
Yeah.
have to put it into the notebook. That's what I was asking because
you have two
you said it can't
choices.
be like loose paper, right? So I'm asking, do I just like staple it to the
Staple it, yes. You have two choices, Samara. You can rewrite it right into the notebook, or you can print it out, copy everything in, and then staple it into the notebook.
okay.
That works. It has to be physically attached into the notebook. If it's just loose leaf, it doesn't count. Does that
And
make
yes, I only had 2 questions. The other one was if we miss a section, is it just locked like forever, or are we able to get like even like partial credit?
You're able to do the post lab and the pre-lab. Results is locked. And the reason I do that, Samara, is because I like to grade everything at the same time. If you submit things late, then I'm not giving you the same treatment as others. And generally speaking, I know this for a fact, I generally am more lax with my late reports than I am with the ones that are handed in on time. That's not fair. So that's why I came up with that rule. I give you a week to do the reports. Like this report for density is not due until next Tuesday, next Wednesday at midnight. Okay.
Okay.
So I think that's fair. And besides, I hate to do this. No, I don't. I'm an old guy. Old cranky people do this. This is going to teach you a life lesson that you have to submit things on time. All right.
All right.
Sorry.
That's all right. I'll figure it out. But those are my only 2 questions, so that you can go back to helping Max and Charlie.
No problem. Arthur, do you have a similar thing? Do you have a simple question? Arthur, are you asleep? I actually did put somebody to sleep the other night. And everybody let him sleep. They didn't want to wake him. Okay. Now, Charlie, you were asking if that was the.
Oh, have a good day.
Samira, have a good day yourself. You were saying, was it always the top one that designated these significant figures?
Yeah, and now that makes more sense the way you described it. Yeah, I understand.
If I do something like this, if I put 45,000 and add 4,000 to it, you tell me, Charlie, what am I limited by? Which place do I report my final answer to?
To the 1,000 place.
To the thousands place. So this ends up being 49,980. Since it's to the thousands place, this ends up being 5.0 e to the fourth.
Cool. And do we have to report it as 5.0 times e to the fourth, or can we report it either way?
All right. The only other way that I know of that you can report it out is you can report it out as 50,000 if you put a horizontal line above the last zero that's significant.
Okay.
It's an old archaic way of doing it. but that is the way that they used to do it.
I remember that now.
Okay, so yes, you can report it out with that horizontal line. But if you just
Okay.
report it out as 50,000, if you just report it out as 50,000, that literally tells me there's one significant figure, and that's the 5.
So if you were to draw a line on this one, it would be like through the, after the 5 and the 45,000 and after the 4 and the 4,000. Remember you said that vertical line?
Oh, yeah. It would be after the 5 and after the 4.
Okay.
And so
Yeah, that makes sense.
And then for multiplication division, you report to the least number of significant figures regardless of the place.
Yeah.
Got it. Cool.
How does that work in regards to like constants? So let's just say you're converting from you're trying to find the moles in something, or you're trying to find the molecules in something. So do you look at the significant figures in Avogadro's number, the 6.002?
yes.
Okay.
Answer your question, Charlie. 2 sig figs times 4. Always do the rough math. This means that my final answer has 2 significant figures. So I start from the left. This 1 and this 5 is the last significant figure I can report out. I look just to the right. That is a 5, so it gets rounded up. So the real answer is 160,000.
Or 16.0, or I'm sorry, 1.6 times e to the
6.
Six.
Fifth,
Okay.
fifth.
Cool.
Okay, now, I'm sorry, Max, I was concentrating on this thing and not fully paying attention.
Yeah,
Could you
that's
repeat
fine.
what you just said?
No, I was just wondering, like, I think you answered me, but
Okay,
yeah,
All
but
right.
like constants, like Avogadro's number, when you're doing like conversion
All right.
stuff.
Avogadro's number is not an exact number. Okay,
Okay.
so if you're dealing with number of molecules and say you have the question is how many atoms, right?
Okay.
You never want to limit your significant figures. This is your data. Okay. It's data comes at a cost. It's precious to you. All those significant figures are very, very precious to you. So you don't want to lose them. Okay. What you do is you alter everything, every constant you're multiplying it by to get to the point where that will not limit your significant figures. Unfortunately, if I do this, I'm going to get out of here, I think.
No, you're fine. Yeah.
What I
just
would do is I would Google Avogadro's number and take it one more place out. I know the first 4 numbers are 6.022.
Yep.
I would have to
And-
Google Avogadro's number to find out what the 4th
Times
place past the
10 to the
decimal
20.
is.
Oh, okay.
All right.
Oh, all right.
All right, just like this. If I wanted to know how many moles, right? If
You would
you're
divide by the grams per mole of that atom to the significant figures that you have for the mass.
okay, you would divide this by 55.85 is not good enough. That's not good enough because of the fact that this number is not exact. This number would limit your data. You always use an atomic weight that has the same number or more significant figures than your number of grams you're using, so that you don't
Okay.
truncate significant figures in your data. That's the general rule for what you do there.
Is there like a periodic table that has like that many significant figures?
Yeah.
Or like, I guess basically are professors going to give you numbers that could possibly be limited by the grams on the periodic table?
It's possible.
Oh, wow.
All right. But what you do to save your ass is you put in an explanation. Let's see. Good God. I know it goes out further than that. Going to my third reference material.
Also, Max, did he say we're going to receive a periodic table on the quiz or on the test, I guess, like a detailed periodic table?
I don't know if it's for this class, but I know we need a periodic table, like our own. I'm not sure if that's this class too.
Can't believe I had to go to 4 books to get the number. You would have to use 55.845 if you have 45.687 grams of iron. And you know what I would do? Seriously, Max?
Yeah.
Literally speaking, if it's in a face-to-face class, that's when you raise your hand, come up to the professor and say, hey, I know that this has 5 significant figures, and I know, but you've only given us 4 for the atomic weight. So is it okay for me to report it out as 4? Because what you're doing is you're telling him, hey, you know the rules for
Yeah.
sig figs, okay?
Yeah, you have the understanding, so.
And again, if I was encountering this in an honor log test, what I would do is I would type out real quick, hey, you've only given us 4 significant figures because of the atomic weight. So therefore, that's the reason I reported this out as 4 sig figs. Make sense, Max?
Yes, yes, sir.
Got it, Charlie?
Yes. And then my question was, will we receive a periodic table on the test that we have to take, or can we
Yes.
have one out? You don't?
Yes, either way. Charlie, either way.
Okay.
I generally go through and see the atomic weights that are on my periodic table, and I try and do the test beforehand, and I try and see if there are any problems like that.
Okay. And just for, what was that? I was having trouble with, I honestly, like the last chemistry class I took was literally 6 years ago. So I'm trying to like bring it all back right now. But the, what's it called? The ionic charges for all the elements, will
Okay, do you have your periodic table in front of you?
I can Google it.
All right, you need to print one out.
Okay.
Yeah.
All right, you need to print one out. All right, generally.
There's kind of an easy way with that. It's just like the first 2 columns are usually the cations. They're usually plus 1 and 2 charges.
But then you get into like, so I understand that part and like that I can memorize, but then it's the ones that
Like
are
polyatomic?
Yeah.
The polyatomics. All right. This depends upon your lecturer. There are some people that believe that it's important for you to memorize this crap. I agree with you, Max, 100%. That's why all my tests are open book. I mean, I think it's more important for me to be able to see that you understand that if NO3 is a -1 and you put that with aluminum, you need to make a parentheses and put 3 of them there. That seems to me just a no-brainer. You guys have access to computers. I never even, you wouldn't have believed the computers. We used to have a computer class in which we used to have a stack of cards. They used to have a stack of cards that people had to punch out things. And then basically you would run this through the computer and it would print out a picture of Snoopy in Sopwith Camel. Okay. That's the nature of what I grew up with. You guys just have instant information. And it makes no sense to me for me to make you memorize NO3 when all it's going to take you is 3 seconds to type it and then 1 second to hit the button. So that's why I don't do. But Having said that, there are other people, especially old school people, that really want you to know that NO3 has a -1 charge. You just have, that's something that you're going to have to figure out with your teachers as to what they are making you memorize, and pin them down. Pin them down on that, okay?
And then do you know Professor Warden at all?
Yes, I do. Very good guy.
Okay. So
If I-
similar
if I
thinking
was-
to what,
To be honest with you, if I was of the teachers at SPC, he's the one I would recommend, especially to kind of like nurture you back in.
cool. Okay.
Okay.
That's what I'm taking for the regular chem course.
Dr. Warden is very, very good.
Cool.
You're Charlie, I'm gonna send you my this is the website I use for my cations, anions, and all the the charges associated with them, and they have like the polyatomic ones too.
Oh, that's awesome. Yeah, I'm gonna
But
bookmark that. Thank you.
Charlie, print
Yeah.
print out a periodic table of your own. Okay.
Mhm.
And once you do that, just stay after again on next week, and I'll show you how, I'll tell you how to label it. Okay.
Okay. Sweet. Thank you so much.
No, it's no problem. Now, you
That
want
helps
to
a lot.
do, did you want to specifically go through the
The
quiz?
quiz. I figured it out for each one, so that's fine. And I have to bounce too. I have to go to work. So
Okay. As I said, I'm here for you guys.
sweet. Okay. Thank you. Yeah, that helped a lot. Understanding.
No problem.
All right.
Max, any other questions?
No, I'm actually gonna head out myself.
So if I leave this on, how long do you think Arthur would be there?
Forever. I feel like there's probably some glitch with his Zoom account,
Maybe.
Arthur, you there?
or he just turned it on. And
No. Either that or he turned it on and then left to go do something and then is going to come back later.
Yeah, I think so. I think that's what it was.
Yeah.
Anyway, you guys take care. I'll see you next
All right.
week.
All
Thank
right.
you.
Have a good
Bye.
day. Thanks.
Have a good day.